Welcome everyone to the session about Azure Sentinel, the Ultimate Integration Guide. The next 45 minutes I will give you a brief introduction to Azure Sentinel and the important steps you need to consider when you want to integrate the solution in your environment. First things first, I want to thank all the sponsors listed here. Without them, this beautiful event would not be possible. Although it's virtual, I think the organizers have done a great job. And of course, the sponsors did also their job making this event even possible. So thank you. A little bit about myself. My name is Michael Rueefli. I'm based in Switzerland, working for Scopewise as a solutions architect. Being in this space quite a few years, I'm a long-term MVP, an Azure MVP. In my spare time, I do some blogs from time to time. I'm a public speaker as well, and in the spare time in winters I do skiing. In summer, I like to jump out of airplanes. So let's start with the first slide. We all know that the security landscape is a bit different in the cloud, right? So with the digital transformation, we are shifting into different perimeters. So the classical perimeter like your on-prem firewall is not sufficient anymore to protect your assets. With assets, I mean identities, devices, apps, data. So to protect them, we need different metrics, and we also need a different set of tools protecting our traveling users working from home, working from almost everywhere on the planet. Besides protecting our assets, we also need to identify when something is behaving abnormal. So user behavior analytics, device behavior analytics, threat protection are all this kind of stuff we need to care about. But this session is more about the management of the tooling around our, let's say, security posture. So Azure Sentinel is clearly a thing which lives in the cloud security management scape. So we need the right tooling to combine all the security tools we have from Microsoft and also from third-party vendors, of course. So Azure Sentinel is in fact a security event, incident and event management system, which helps us to, let's say, identify things happening throughout the Cyberkill chain. So we might be already familiar with the Cyberkill chain, which is illustrated here in the form of a user receiving a bad email. The user is opening the email, and from there things are happening. So this is one way an attack could happen, of course. Email is still one of the top 10 use cases for malware and threats being introduced into your company, into your environment. But the thing with Azure Sentinel here is we want to detect anomal behavior of, as I said, devices, identity, and applications. So whenever things are not behaving normally, I will talk about that in a minute, what normal and abnormal usages are. We want to detect that and maybe also respond manually or in an automatic way to this kind of events. So SIEM is all about detecting threats and anomalies, and of course react to them. So maybe we want to react by just investigate what happened. Maybe we also want to go a bit further to isolate devices and identities from being, let's say, more intrusive even. And this produces some challenges. We have some challenges in the cloud with traditional SIEMs. So traditional systems, they require a lot of infrastructure stuff to being operated and maintained. A lot of data is coming in from the diversity of all the sensors and analytics and metrics. So we have a lot of signals. We need to collect and normalize the data, which is usually a heavy job for one or more person. And regarding the tons of signals we get out of the cloud, not only the Microsoft cloud services, also from all third-party SaaS applications our company might use, we are just not able to catch up with all the important stuff besides, let's say, from all the false positives or regular log data. Additionally, the traditional SIEMs have a little bit of problem with connecting to the various third-party products. So we need to integrate in a way that it's more efficient and we can concentrate on our business-related processes. Azure Sentinel by itself is a cloud-hosted service. So this service lives in Microsoft Azure, and it's a cloud-based SIEM, which is leveraging artificial intelligence, machine learning, and threat intelligence capabilities. So that's the beauty behind it. So we don't have this manual data normalizing and collecting jobs we need to do with Azure Sentinel, or at least it's on a very low level where we need to manually interrogate by creating our own analytics rules will then, which will then create incidents. To them, somebody has to react. Okay. Azure Sentinel has a few main components. The most important ones I've outlined here. So of course, Azure Sentinel needs to have a basis of log data. So data which can be analyzed by Sentinel and its various surrounding products. This is basically living inside log analytics workspaces. I will talk about that in a minute in detail. So from there, we may have alerts leading to incidents. We want to have a visualization of all the important data, the alerts and the incidents, which is done by using the Azure Workbooks for visualization and dashboarding. If we want to do manual hunting, forensics, or even just explorative security posture analysis, we have the hunting queries. The playbooks are used to automate responses to incidents. So maybe we have a clear view what should happen when we have a rogue device being infected by malware and so on. And we have the notebooks. Notebooks are Jupyter based. They are for advanced hunting and visualization, especially used in cases where we have a defined process from manually documented steps as well as scripted steps to investigate some portion of a incident or the whole incident. So to give you a brief overview, I will jump right into Azure Sentinel right now. So what you see here is the Azure Sentinel overview portal, or let's say the part of Azure portal which is giving me the overview of Azure Sentinel service. The first thing we see is we have different scopes from a time perspective, so we can change easily between those time frames, or we can even choose a custom range. So if you want to go back more than, let's say, 30 days, we can select the custom time range here. But the most important thing is at the first site, we have a indication what's happening. So how were, in this case, the last 24 hours? Did we have some anomalies? Did we have a lot more alerts or security events than we had before? If we go back to the 48 hours, or if we go back to the last 30 days, we might have an indication what's happening in this time frame. On the right side, we have the overview of the incidents. In fact, the last 5 incidents here, the data source anomalies. So if we have a lot of more data coming in from a security perspective or from an activity perspective, we have some indication here. If we jump to incidents, we will see the last few incidents as well here. I can search for an incident. Again, I can dive into a custom range here. I want to have all the incidents from the last 4 months, for example. I want to see all of them, also the closed ones. And then I'm going to search maybe for an incident like I know someone did execute Mimikatz recently, so I can see the incident here. I can dive into the incident, view the full details, and so on. An important thing here, if we go back to the last 24 hours, is the entity behavior. So if we have incidents, we want to dive into the details of the incident, what happened. And the entity behavior gives us an indication of the entities affected, or let's say producing those type of incidents. In this demonstration here, I have a demo machine and I have a demo user, which indicates that they have some alerts related to them. So if I go to this demo machine here, this is in fact the machine entity. I can see the history of this machine, what happened in the past. Again, I can select the time frame. I can see the last few incidents and alerts which occurred on this device here. I can also see that in the last few hours I had more than the usual alerts, or let's say the usual events coming in from this device, and this gives me an indication if this device is happening, if this device is behaving normally, or on the other hand, it's behaving anomalous. And go to the investigate part of the incident, and I will see that this demo machine has quite a few anomalous processes and actions going on. I can dive into these actions here. I will show that in detail later on. So for now, this should be sufficient to give you an indication what Sentinel can do for us, but let's dive into the secret sauce. Sentinel is based on Log Analytics Workspace data, and therefore we need to take care about how we, let's say, design our Log Analytics Workspace infrastructure. Azure Monitor Log Analytics Workspaces is the place where Azure and Microsoft 365 and also other components and applications can send or forward their logs to. We have dashboards called Workbooks to visualize the data. We have a query language, the KQL, called Custo Query Language, which is used to further investigate and do analytics on the logs and alerts incidents coming in. It's an integral part of Sentinel. So if you onboard Sentinel, you need to onboard Log Analytics Workspaces first. To start with the access, the role-based access, Log Analytics Workspaces have their own let's say RBAC controls. Like every Azure resource, we have contributor, owner, reader, so whatever, but we have 2 layers of giving role-based access controls. So this is the whole workspace on one side, and if required, we can even set the permissions on the table level. Table means a type of log being ingested into the workspace. So that's the role of Log Analytics permissions, workspace or table layer. The other layer is the Azure Sentinel service by itself. So someone may have the right to configure Azure Sentinel, to configure the rule sets, to view or operate on incidents. And here also we have different RBAC roles which we can assign to different type of users. So for giving you an example, maybe the security operator, the analyst only needs to work with the incidents. So there is a role-based access role called Azure Sentinel Responder, which has the right to work with incidents and alerts. So this part here is important when you design your workspace infrastructure. The most easiest way if you have a single tenant and a single workspace. So we have a single pane of glass. It consolidates all the security logs and information from all your products into one single workspace. It's easy to query all your information. Every feature is supported having a single workspace, but there are also, let's say, downsides. So data governance might be a limitation here because maybe you don't want to have all the security logs and all the information in a single workspace, making it difficult to grant access to different types of users, departments, or even companies inside your company organization structure. But going with this architecture is the most easiest way, so with the least overhead and administrative efforts. Another possibility would be to have a single tenant but multiple workspaces. So in this case, we have our Azure Active Directory, but the products send the log data and the security information into different workspaces. So maybe we need this if we have a, let's say, a regulatory or data residency requirements. So security logs from solutions running in US data centers should be, the logs should be forwarded into this workspace. And in this example for Swiss applications or services, the logs should flow into this security workspace here in Switzerland. Just give you a hint here, it's not very flexible with all the services in Azure and Microsoft 365 to partially forward some logs into one workspace and other logs into another workspace. Giving you an example here, Microsoft 365 audit logs, which includes all security information about the Defender, information protection, SharePoint, Exchange Online. You cannot split up the logs into different workspaces. So it's not that easy as it seems in this architecture here. The third design is when you have multiple tenants. Of course, you can have one tenant and one workspace, or one tenant and multiple workspaces. But in this case, in this scenario here, we don't have a single pane of glass because we have different, let's say, Sentinel scopes. So one is for tenant 1 and the other one is for tenant 2. So we need to do the work really twice. There is no single pane of glass, no central control over the two tenants here. Not really ideal. I would not recommend to go with this scenario. If you have multiple tenants, then there is a way to combine the two, let's say, security or log analytics workspaces into one Azure Sentinel scope. This works over Azure Lighthouse. For those who don't know Azure Lighthouse yet, Azure Lighthouse is nothing more than cross-tenant RBAC. So I can assign a group from tenant 1 permissions on resources on in subscriptions attached to tenant 2, which is, let's say, possible in a similar way to one tenant and multiple workspace scenario, just with the difference that we need to onboard Azure Lighthouse first, so we can give one group of users access to both workspaces living in different tenants. Again, here we need to, if we want to query the log spaces, we need to create so-called cross workspace queries. So a query for a, let's say, a holistic view should span then multiple workspaces, which is possible, but it's harder to create these queries. A little bit more effort has to be done here. So as long as you don't have special requirements, I would target the first architecture with one workspace per tenant. And if you have multiple tenants, then this architecture would be my suggestion to go for, to consider as a target design. Multiple workspaces, I already mentioned it a bit. It produces a kind of an overhead because we need to define some portions of Azure Sentinel for multiple workspaces. Analytic rules, we need to connect the data connectors for each workspace. We need to define the hunting rules for each workspace. And if you have that situation, especially you might be in a, when you are in a service provider scenario, security operations center as a managed service, then you want to connect to different customer workspaces, for example, you need to automate the stuff. So manual configuration would lead into differences, into, let's say, unexpected behaviors. So we need a way to automate that. One possibility is to use the Azure Security Insights PowerShell module, which gives us the power to automate the analytic rules, the connector configurations, and also the hunting rules. Even if we use this automation, we have some portions of the solution which need to be done manually still. But let's say the vast majority of the configuration efforts are in this area here. So this would help us to keep the configuration synchronized across multiple workspaces. So how does Azure Sentinel gets the data it will analyze? Data ingestion is configured on a workspace level again. So Azure Sentinel is analyzing one or more analytics workspaces. We then have connectors, so-called data connectors, which we onboard to forward data into Azure Log Analytics Workspace. So what this data connector do usually is just collect information from the various products and import or forward the logs from the products into the workspace. At the meantime, each data connector gives us usually some out-of-the-box analytics rules or let's say alert and incident creation rules. It also gives us a basic set, usually a basic set of dashboarding. So each connector usually contains at least one workbook where we can visualize the data coming in from those various products. So these are built in, we just need to onboard the connector. But of course, we also might have on-premise systems which we want to use as a information for Azure Sentinel to be analyzed there. So we can forward logs using monitoring agent for Windows and Linux. But we also have a common event format collector running as a container here in this example, which can then be used to forward general syslog messages from various security appliances into Log Analytics Workspace. And therefore we can onboard a connector maybe from F5 or from Cisco products on Azure Sentinel. So the third-party products are then also analyzed by the connectors and the rules behind the connectors from the third-party vendor. It's still Azure Sentinel which is analyzing the data, but in this case here for third-party products, the intelligence, what is normal and what is not normal, is of course delivered by the rules from the third-party vendor. Logstash is also an integration which is out of the box. We can onboard applications or existing Logstash configurations. And on top of that, Analytics Workspace has a general REST API, so we can forward any type of logs into Log Analytics Workspace. Any type of custom logs you can imagine is a possibility to leverage the REST API for data ingestion. Logic App Send connector is another way to forward information and log into Azure Sentinel. So there are various ways how Azure Sentinel gets its data from. Where the most easiest part is, of course, to leverage the out-of-the-box connectors from the Microsoft products. So to show you that, I'm jumping over to Sentinel and show you the data connectors. So the data connectors here, I've already onboarded in my environment a bunch of them. Azure Active Directory, so the audit logs, sign-in logs from Azure Active Directory, for example, they are already onboarded. If they would not be onboarded, this connector would not be marked as green here. I go to the connector page, and as long as I have permission required to do that, I can configure the connector to forward the sign-in audit logs into the Log Analytics Workspace connected to Sentinel. Another example is, of course, Defender, the various Defender products. We have Office 365 connector here. It's Defender, it's Cloud App Security, it's Defender for Identity, it's the Defender for 365, and the general Office 365 audit logs I talked about 5 minutes ago. Also here we have the connector page. We just need to onboard the connector once, and from there on the data from Office 365 is flowing into Azure Sentinel. So every connector, as I said, has its own data collection intelligence. It also has its own configuration regarding the rules and the workbooks or dashboards. So if I open the connector, I can see the properties of the connector here. I can go to the log analytics and jump right into the raw logs provided by the connector. Speaking about the analytic rules, so each connector usually comes with a basic set of analytic rules, which can be enabled here by using the templates. So I can create a incident collection rule for, let's search for Office. So there is a special rule for Office policy tampering. I can create this rule, and all the intelligence producing the right query is built in, so I don't need to, let's say, engineer my own rules for the built-in products. So once this connector is active, it collects the data, of course, and Sentinel is going to start analyzing the data. Going back to the workspace, I have connected a single workspace. So if you go to Azure Sentinel Workspaces, you can see that I have a single workspace. And the thing I mentioned at the beginning is if you have multiple workspaces, you need this type of configuration multiple times. So data connectors, analytic rules, and also the activation of the workbooks need to be done for every workspace. There are third-party data connectors as well. I mentioned it already. This space is growing month by month. We have tons of third-party vendors providing out-of-the-box connectors. F5, 4D, Checkpoint, Palo Alto, and so on and so on. Symantec. So the list is growing month by month. Analytics rules, I talked about that part of Azure Sentinel a bit already. We have automatic hunting rules and we have a manual hunting rules. So automatic hunting rules are there to periodically search for anomalies, or a lot of the out-of-the-box connectors are using REST API connection between the product, like Defender for Endpoint and Azure Sentinel. They are talking over REST APIs together. So once an alert is produced in Defender for Endpoint, it will reach Azure Sentinel as an incident if we enable that. So analytics rules are there to raise alerts, and alert rules or alerts are there to raise incidents. The basic difference between an alert and an incident is an alert is just a notification that something happened. The incident itself then can combine a lot of alerts into a single object. A lot of events are combined to one or more alerts. So events lead to alerts, alerts lead to incidents. The big difference here, if I raise an incident, then someone has to investigate it and to work with it. So if nobody is working with incidents, then the incidents are in the status of open and they stay in the status of opened. So we need to have someone then being in charge to investigate the incidents and maybe react and react to the incidents and talk to the administrators or the security staff or whatever should happen then when an analytics rules has triggered an incident. So going back to Azure Sentinel portal, we have those analytic rules. Analytic rules are basically of two types. They are automatically created by the connector if we choose that, or they are in terms of manually or automatically created scheduled rules. So all this type of analytic rules here, they are produced by the product integration on a REST level. So Azure Active Directory, Defender, Cloud App Security, all those products are talking over REST API with the security graph and Azure Sentinel. All the other stuff are so-called scheduled query rules or scheduled analytic rules. A scheduled analytic rule can be produced like this, for example. I create a new scheduled rule. I give that a name, test rule 1. I select the Mitra tactics, maybe this type, for example, is initial access. Severity, I can select the severity. If my query will produce results, then this should raise an alert of medium severity, enabled or disabled. That's the status of the rule. Next is the rule logic. So I need to provide a query. Let's say I want to use the sign-in logs. Again, this is the KQL, the Custo Query Language here. It's the same you use in Log Analytics natively. And then where user principal name contains demo, for example. I need to map the entities, which is an important thing. So Azure Sentinel combines similar alerts and events and incidents regarding the entities. So if I have similar alerts coming from the same entity, Azure Sentinel automatically combines it, and it also leverages then the entity view we have seen at the beginning, so I can see all related alerts and incidents from this particular entity, and currently we have this type of entities available. So I need to map the account entity to maybe the user principal name. Why not? That's a good idea. So I need to define the query. I've done that. Then I need to define how often this query will be run. So the minimum is actually 5 minutes. So every 5 minutes this query will be run. I look back over the last 10 minutes, for example. And if the result is greater than 0, I need to define what happens if I have multiple events, if I want to group them to get to a single alert. Next is, do I want to produce an incident for that? Default is yes, but I can also disable that. And then again, I can configure the alert grouping. So if multiple alerts coming in, I can define a grouping. So for the next 1 hour, I don't want to have multiple incidents coming from the same source of alerts matching the same entity. Let's say if this alert is produced by the same entity within the next 1 hour, I don't want to have multiple incidents, so the alerts are grouped and attached to the already existing incident. The last step is to decide if I want to automatically trigger a response in form of a logic gap. We will see what that means in a bit. And my analytics rule is created. That's the manual step using the graphical user interface. I already mentioned it. The PowerShell module gives you a way to import and export the analytics rules, so you don't have to do that manually if you have to configure a lot of workspaces or a lot of customers, if you're a service provider, for example. So this type of rules are scheduled rules, but there are also a lot of rule templates. So again, rule templates can be of a scheduled type, or they can be of a type where the product directly talks to Azure Sentinel using REST API. So we don't need to query actively logs inside Log Analytics. If an event from Azure Defender is raised inside Security Center, then we can create this rule here and decide whether an incident should be created for Azure Security Center alerts or not. Incidents are raised by Graph Security Alerts. This is basically the REST API part where the products talk directly to each other, or it's raised by a Log Analytics scheduled query rule. The incidents are enriched with related information, alerts, events, and security graph-based exploration. In our little example here at the beginning, we have seen an incident coming from a Windows 10 device. This was a suspicious PowerShell command line which was executed, or suspicious behavior from a CMD exe, and I can go into the investigate button. I can see the processes from this user running on this machine when the incident happened. I can see the related alerts regarding this type of process. I have two. If I go to the entity of the user, I can see, oh, this user is producing a lot of alerts. I can jump right into the raw events which led to this alert and to the incident, of course. So this gives me a summarization of all the alerts attached to the same entity, in fact, to the user, which was responsible for executing or exiting the processes, or maybe opening a rogue file. Okay. So working with incidents is important. As I said, you need to take care of the incidents. So if we have an incident here, it does not make sense that this incident is only produced here in the portal and nobody cares about it. We need to investigate, and maybe we need to assign this incident to a particular user. Maybe I'm going to assign this type of incident to myself. Severity, I can change the severity. Well, this was marked as medium. I will consider this as a high severity incident for now, and the status is active. So someone, in fact, me actually, is working on this incident. I'm gonna add a tag like demo and apply the change. So now someone has been assigned to the incident and is actively working on it. If the problem is solved, or let's say the issue is considered as let's say false positives, then we can safely close the incident here by just giving it the close status. Let's say false positive only test attack. And close it from here. There are various ways you can interact with Logic Apps and Microsoft Flow and also other techniques to automatically close incidents from another product if you want to do that. Workbooks are for visualization. You might be familiar. I think you are. If you have ever used Log Analytics, these are the same type of workbooks. Depending on the connector, each connector comes with a set of workbooks to visualize, let's say, the important part of the data. Also focused on anomalies, which type of events we have the most, failing logins from which users in this example. But again, this is nothing special to Sentinel. This is log analytics, workbooks, or dashboards, however you want to call it. So an important thing is we don't only want to react in a manual way to incidents. Maybe we have some specific incidents where we already know how to react to it. So maybe we have a rogue device which is being infected by malware, cryptoware, whatever, and as soon as this is detected by Defender for Endpoint, an Azure Sentinel incident is raised, but therefore we don't want to wait until someone in person reacts to the incident. If this happens, we want to isolate the device instantly. So automation of the response to security incidents in an automated way is an important thing. How do we do that? We use playbooks. Microsoft calls it playbooks in Sentinel, but in fact they are logic apps. So logic apps is a type of resource in Azure which is capable of producing a business process in an automated way. So a workflow is a logic app which can, in this example, get the incident data and then do something with the information behind the incident. To give you a little bit context what that could do in your environment, I'm going to show you an example here. I have a rogue machine, it's connected to the internet, it has been, might or might not be infected with a malware, but it's the machine which we had in the incident a minute ago. So we have a suspicious behavior by Microsoft Word followed by command line, all from the same device. So I consider this as a rogue device. So what is possible now, I can go to full details and I can view the playbooks which I can trigger from this type of alert here, and the playbooks, for example, I have here. One is the isolate machine. So in this case, I'm sure I want to do that, run, and behind the scenes, this playbook is going to be executed. It runs, it already succeeded, and in a second we should see, yeah. So what happened is the logic gap took the information out of the incident. So logic gap knows now it's this device SCDemo02, which is considered to being harmful, and the defender for endpoint is now triggered to isolate the device. So this device cannot do any more harmful stuff in my network. The logic gap behind the scenes here can be triggered manually, as I did now, or it can be triggered automatically. If we remember when we created the incident collection or the analytics rule, the scheduled query rule, we can link a logic gap. So every time this type of incident would occur, this logic gap can be triggered automatically. So it gets the information of the incident. It gets the host, so from the affected entities list, it gets the device being affected, and then it executes the isolate machine action, which is a built-in action in logic gap, and we have seen the result, what happens. Of course, I need to go to the Defender for Endpoint portal and take this machine out of the isolation so it can be used again. This was only for demo purposes. Let's go to the device and release it from isolation. This was only a test, so it's safe to revert the isolation. And again, this device has network connectivity again. So this is an easy example how you can integrate with automated responses leveraged by or produced by Azure Sentinel incidents. An important thing is how can you integrate Azure Sentinel into your maybe existing SIEM systems. One way is you only forward alerts produced by incidents into your on-prem SIEM system, which you might already invested a lot of time and money, so you want to keep it for some time. And then you can forward alerts into this on-prem SIEM. In this case, it's IBM QRadar, but various other products also have connectors to Azure Sentinel. Then the way is that you only forward alerts or incidents to your on-prem SIEM to have a holistic view on-premise. A bad decision would be to forward the raw logs produced by the various data connectors over techniques like Event Hub into your on-premise systems, which is technically possible, but then you would pay usually on this side of the solution, excuse me, and also on this side of the solution you pay usually by the amount of log data which is being analyzed. And again, if you only forward the raw logs, you don't leverage the benefit of the AI and ML capabilities here. So you have to create your own rules and your own set of logic if something is behaving normally or abnormally, which is really not the way I would go. So this type of architecture we have implemented several times for customers leveraging their on-prem SIEM, and they didn't want to have two holistic views. In fact, they wanted to have one single holistic view. But what happens then if they raise an alert from Sentinel in their on-prem SIEM, beside having the holistic view, they are going to analyze the details in Azure Sentinel, which is my suggested way to go forward if you want to have an integration with your already existing system. From the side of costs, we pay for log analytics data. we pay for data ingested per month in terms of gigabytes per month. We also pay for data retention, which is more than 30 days. So 30 days is included. If you want to have more, then the costs are going up. From a Sentinel perspective, it's the data ingested and analyzed per day, and also here we have a data retention, which is a default of which has a default of 30 days. If you want to have more, we need to increase the data retention. The beauty of having Microsoft products connected to Azure Sentinel is this. So this is officially documented. You find the link below the image. So all the Defender, Office 365, Azure activity, Azure AD activity and audit logs, all the logs you connect here can be ingested in with no additional cost for Sentinel and Azure Log Analytics. So you don't pay Azure Sentinel for analyzing the data, which is coming from the Microsoft Cloud Service product, in fact. So, of course, you need to have some licenses. Azure AD log data forwarding requires a license. In fact, it's a P1 license, either both separately or within a E3 or Enterprise Security add-on E3 or E5. But mainly the important information here is, although if you have thousands of users in your Azure AD and you're using Office 365 extensively, this can produce a lot of logs, but you're not paying from a Sentinel perspective for this type of logs. Another thing is if you forward Windows security event logs from on-prem or from Windows virtual machines running on Azure or Linux machines, then this type of data is not included in the free tier, so you pay for the gigabytes per day analyzed by Azure Sentinel. How do we start? To close this session, I want to give you some hints. So before you start with Sentinel, you need to think about having a SOC team. So someone has to take care about the connectors, the rules, and when you have incidents and alerts which are raised by Sentinel, someone needs to take care of them. So you need to have a team which is responsible taking care of what happens in Sentinel, and also have a process of analyzing, investigating the data. What happens if something happens? Choose the workspace design wisely. Go with as few workspaces as possible, as many as required. But yeah, I really would go forward here in a conservative way. So start with one, if not other regulations force you to have multiple workspaces. Onboard common connectors first. So if your scenario is modern workplace, Team, SharePoint Online, Exchange Hybrid, Exchange Online, then onboard all the common onboard connectors first, and then start with the built-in analytic rules. Don't bother you with creating manual rules first. Start with the built-in connectors and the built-in analytic rules. They are already giving you a very, very good starting point. After that, think about what different analytics rules could be worth of integrating. We as a company have quite a big rule base we are using for customer projects. So for example, we want to detect if someone does access elevation Azure AD, we want to detect if someone changes a conditional access policy in certain ways, and we want to produce an alert on that. This is all done using custom analytic rules. So with that, this was a really, really short introduction into Sentinel, into some important parts you need to consider before starting with the service. And with that, I want to thank you for your attention, and I wish you a nice and comfortable rest of this conference. See you.